Coupling. This is an important design concept, how we design loosely coupled programs as opposed to tightly coupled programs. And there's a short definition here. A loosely coupled system is one in which each of its components has or makes use of little or no knowledge of the definitions of other separate components. Okay, so keep that in your heads for the moment, and we'll come back to that definition at the end of the workshop to see whether it makes a little bit more sense, a little bit more context here. So the two objectives we have for this session is explain what it is and refactor code to go from tight coupling to loose coupling. And there's a directory we're going to work from, and so there's some information here about how to run tests and how to learn your code again. But this is the intro that I want to do. I'm not going to spend too long on this, and I want to send everyone away, and then we'll come back and we'll do sort of like that. Go off and explore it in your pairs, and then we'll come back together to discuss. We'll do that a couple times. So in this specific example, there's lots of different ways that coupling can occur, and it's quite a sort of a high-level concept. And we're going to look specifically at tight coupling amongst classes. And so an example of tight coupling occurs when a dependent class, points directly to a concrete class which has required behavior. So if you look at this example, let's have a look at this one here. You can see that the class wallet has a concrete pointer, so what we call like a hard-coded definition of the balance class inside the constructor functions. So we would say that this, at the moment, the implementation of wallet is tightly coupled to the balance class, right? And we know that, or we have some ideas behind that, because if we needed to change or have a wallet that's had a different starting balance, we'd have to go into our wallet class and update it. And then we'd also have to update our balance class, perhaps if we need to change some of its behavior. So we'd be changing things in two places, and this gives a good sort of indication that these classes are tightly coupled. This is something that you've probably all been doing so far, and that's absolutely fine, but we're trying to think about different ways to increase essentially the modularity of our programs. How do we break our programs into smaller pieces and reduce the amount of knowledge between these pieces? The less each part of our program knows about each other, the more easily we can substitute it or extend it or change it. And that's good, all right? That idea is good. Now, there's clearly going to be a trade-off. If you go way to the extreme of this and have everything incredibly decoupled, then the sacrifice here is essentially understanding how the system works. So there's always a trade-off. But we're going to focus on how do we decouple? How do we go from tight coupling to loose coupling with classes this morning? And we'll come back to it next week and the week after. All right, so this is just something for you to think about as you write your program, as you write your airport class, your airport challenge, other challenges. How can you go from tight coupling to low coupling? So in this case, if we needed to change, if we needed a wallet with a different starting balance, we would have to go into the constructor function, actually change it before we use our wallet class, and that's not good. So one way to move towards a looser coupling in this specific example is to move the pointer to the class definition outside of the class. All right, so from here to removing this and saying we're going to now put it over here. So it's no longer part of the class definition. Still has the same, same result. We can still use balance inside of our wallet, but we can change different balances, or we can use even an entirely new object, because it's no longer hard-coded inside of the function body. So we're now just referring to the abstraction, like a named argument, and hoping that we pass it at what we call runtime. Runtime is when we actually use our objects or call them. This is a case of creating a new wallet class and passing in the balance at runtime, rather than having it hard-coded in the function body. So two important things here. One is we're now no longer referring directly to the balance class definition itself inside of the class wallet, but we also rely on the interface to balance. And we understand the balance. If we only looked at this code up here, the interface to balance is the things that balance can do for wallet. In this case, add and total. So whatever we store in this property cache.balance, we're then going to use it to call the add function and the total function. So if we do have different objects that we pass in here in the constructor function, store it in cache balance, we have to make sure that that object can still respond to the add and total methods. So one is we're using a named argument, no longer referring to it directly. But also, if we say, for example, had an entirely new class, hidden balance, it has to still be able to support the add and the total method. That will be what we call like the interface to this dependency. Another approach is slightly similar. Well, it's very similar. We're still providing the abstraction, cache balance, but we can use what we call a default argument. Now, this allows you to not always have to specify dependencies at runtime. So you don't always need to specify like you have in this example. You can just call new wallet and it will look at the argument, and if it's null, it will then give you the new balance. Otherwise, if it's fulfilled, it goes with what you pass. So you can use either no arguments in this case, or explicitly pass in a different option at runtime. So these are both examples of trying to decouple wallet from balance. Now notice there's still a pointer to the class here, and that's okay in the case of decoupling. It's not quite as decoupled as in this example, but it's still much better. We can still change things without having to change the source code. We can pass an entirely new balance and not worry about changing this class definition. So this is a short example of trying to find ways to, or spotting tight coupling. The smell here is the fact that this class is hard-coded inside of a function body. And that's something that you can pick up on in any of your code. Have you, do you use a class definition inside of another? And if so, how can you decouple it? And the idea is you pass it in as an argument somewhere. So what I want you all to do in pairs is to go through the first exercise this morning. And what you're going to do is apply this technique to a different example, a small example. And then we'll come back and have a look. There are three sort of parts to this morning's workshop. The first part is if you have a look in let's start with the move actually. Let's start with the source folder. The first part is in this file here, move.js. So give me a quick thumbs up if you can see my screen still. Sure, everyone's cool. So here we, in the top of this file, we require three constants: skateboard, car, and plane. And then we have one function, a move function, that has one argument. We've named it vehicle. And there are three if conditions. If the vehicle is an instance of skateboard, do something. If the vehicle is an instance of car, do something. And if the vehicle is an instance of plane, do something. And so your task in pairs is to figure out a way to decouple this move function from skateboard, car, and plane. At the moment, move has to know about skateboard, car, and plane. And so this will work you'll know it works, and I'll show you how to run the test in a second, when you don't have to rely on knowledge about skateboard, car, and plane. You have to figure out how to do that. In using the sort of understanding of the different examples in the intro that we went through, and have a think about how you can do this. Rely on the interface of classes, and then we'll go through it together. So we're going to spend time on this function, and there are 3 at the moment absolutely empty classes. You might need to change these to make your refactor work. And in order to run the tests, you can run this test here. So quite straightforward. We have 4 tests, and we have an extra test to help you think about what would you need to do to extend your move function if you had another vehicle you needed to figure out how to be part of this move. So that last test at the bottom says, I want to be able to use my move and pass it a new spaceship and for it to return a value of moved 100,000 meters. So you're going to run these tests, and they're all going to work at the moment, apart from this last one. And so you have 2 things to do. You have to make this test pass, but also refactor that move function so it doesn't care about what vehicle it is. Currently, the way that you'd have to extend this is keep adding more if conditions for different classes. All right, so feel free to start with that approach, but that's not what I want you to do or to finish with. I want you to figure out how can you refactor this to rely or to decouple this function from these classes. Yeah, that's task 1. Give me a thumbs if that makes sense, or not only it makes sense, but you understand what you have to do, the objective. Any questions? How can I help give you more information what you have to do at the moment? Cool. Okay, I'm going to stop sharing my screen and put you into breakout rooms, and let's go with 7 automatically, and fantastic. Okay, so let's see how far you get in 20 minutes. I'll see whether you need more time after that. And yeah, and then we can go through it together. All right, opening rooms. Questions, if you need me, just ping me on Discord, all right? Cool. Okay, so 20 minutes. I thought I'd go through to demonstrate, and then we can chat about it, and then we can go back into pairs, continue, go on to the next step. How does that sound? Yeah. Okay, so the task at hand was trying to think about decoupling, and I'm sure some of you tried like a bunch of different ways, or maybe just spent some time reading through it. So let's have a look together. And I'll share my screen. So this is the, some of you Zoom windows, go away. You go over there. Cool. So this was the move function we're trying to reduce coupling. And you'll know when you've achieved it if you can remove these 3 lines at the top. If we can get rid of these and not have to require them, then our move function is sufficiently decoupled from classes. So the way to think about this is to try and find an interface to use rather than the classes themselves. So if you had a look through these 3 different statements, you might pick out that there is essentially some behavior for each of these classes that's in common. They're simply just returning a string. So we could remove all of these because they are sort of the same. Each of these are returning a string. So there's something in common here and that we can draw out into an interface. So rather than have to rely on individual classes, we literally could just remove everything and say something like vehicle.move, whatever function name that you wanted to. And so we're going to move from a reliance on individual classes and if conditions, and simply the objects which have encapsulated their own behavior. A skateboard should move 100 meters, a car should move 1,000 meters, and a plane should move 10,000 meters. And this function no longer has to know about each class and simply rely on the kind of class and the interface. So we're going to go from this to something like this. Now this move function doesn't care at all about the kind of classes. So we've decoupled this move function from those classes. We're no longer having pointers of those class definitions inside our function body. But in order to make this work, we have to define move functions for each of our classes. So we have to go to the skateboard first and define a move function. That was something like return moved 100 meters, I think. And the same for the plane. And the same for skateboard. Car is 1,000 and the plane is 10,000. So let's have a look at this. So we've gone from looking at the type of or the instance of the vehicle and looking at the class name and then executing some code and saying, we're not going to worry about it. We're not going to look into the vehicle. We'll just say, vehicle, run your move method. And so we can decouple all of this stuff. And so we are left with a nice, neat and tidy move function, and which is infinitely extendable so long as the vehicle has the interface of move. We could keep adding loads and loads of classes, and this function doesn't have to change, whereas before it would have to. We'd have to keep adding if statements. So in order to get our spec passing, we have a new spaceship here, so we would have to have another file, I guess, spaceship, and create it spaceship.js and have it execute the same interface. So something like spaceship moves, the other one's 10,000, let's go 100,000. I think that's what the spec says. So let's have a look. And we have our spaceship passing test. Okay, thoughts? Going from the previous function to this function.
So Susanna and I did a similar thing where we sort of like set a default for each vehicle to have a distance. But the only concern, but this sort of goes with the method, is that you have to assume it is a vehicle that has that function when you run it.
Yep. Yep, that's a trade-off here. So with this way of doing it, you have to make sure that whatever argument you pass into it supports that move method. And you're relying on the interface to objects, not the objects themselves. And that's good design when you rely on interfaces, not the objects themselves.
So here the interface being the vehicle call, like the brackets and the vehicle.
So the interface here is any vehicle has to have the interface of move. Think of it as like what available functions does the class have.
Right.
The move function here on this one here needs every vehicle to implement the interface of move. Right, it can out do other things, but the only thing that this function needs is that one. Yeah. And you can demonstrate that by adding as many different vehicles, so long as they have the move function. That's the interface they all need to implement. Cool. More thoughts or questions? Cool. Okay, I'm going to send you back into pairs. Continue this exercise. Have a go at doing what I just did. And after that, when you get there, I want you to consider how you can, okay, the intro to this is now what is the point of this move method on line 1? It's a bit of an abstract question, but have a think. And give me some ideas. What is the point of this move method? My follow-up question to this is then to figure out how we can test it better. At the moment, we're still relying on individual classes to help test our move method. So the question is, what is the point of this move method now in order to be able to then test it? Because currently, our move spec needs all of these different classes. And so in the same way that we remove the dependency from any other classes, I want you to then think about how can you remove all of these and still have useful tests. So one approach would be to try and make sure each of the objects is responsible for its return value. So you should make sure each spec for your car, plane, and skateboard has useful tests to make sure they're returning the right things. And then you can reduce the move spec to something. And that's the question after you've gone through the first refactor is what then does this move spec, what should that test? What will be your test for your move function? Okay. So first priority is go through refactor according to something similar that I did to reduce the coupling of your move function. And then secondly, then think about making sure you update your tests for your class, car, plane, and skateboard. And then third, think about how you could remove the coupling to these classes at the top. Yeah? Give me a quick thumbs up if you know what you're going to be doing next. Cool. Any questions? Cool. All right. Let's have another 20 minutes and see how we go. And I'm going to do breakout rooms, open rooms. Folks, this should just be a quick one, just to make sure we're all on the right track. Any quick questions or thoughts at the moment? Any confusions, any examples you want to go through, any questions? So this is meant to be, as someone just said, like abstract thinking, trying to think about a design. So it's good just to spend time thinking about it and working with it and workshopping it. So that is expected. And if you've gone through and decoupled the move function, the next step after that is to make sure you decouple your move test. So you'll know you've succeeded once you no longer rely on any of your classes and your move function is tested appropriately. And therefore, correspondingly, all of your vehicles should have their own tests. So make sure that's the next thing that you do. After that, go on to the wallet and balance example, where you need to decouple those tests and make sure the wallet spec no longer relies on the balance. So that might be another step too much and just focus on the move at the moment. After you've decoupled the move function from its classes and then updated its test to make sure it's also decoupled. That's probably enough for now. If you want to keep going, then decouple the wallet and balance. This is something we'll come back to next week, and we'll just discuss it then. So let's do another 20 minutes, and then gather back in. We'll go onto the mirror board and sort of think about questions and thoughts. All right? How does that sound?
Sorry, can you just re-clarify those steps again? Because you said them quite quickly and I didn't quite catch it all.
Number one, yeah, absolutely. Number one is make sure you decouple the move function, so it should no longer rely on any of the classes. Number two is decouple the move spec. So the move spec itself should no longer rely on any of the classes. So you should move towards a solution that has every class has its own set of tests with a move function. And the move function itself, that's like at the high level, has its own test that doesn't need any of the classes. The next step after that is probably enough for everyone. The next step after that is to have a look at the wallet and balance specs and make sure those are decoupled. All right, fun stuff. This is brain stuff. All right, so we'll gather back in about 20 minutes and see and discuss thoughts on the move function and spec, and we'll go through questions then. Yeah, makes sense. Any questions about what we're going to do in the next 20 minutes? Cool. Enjoy this. See you in 20 minutes.
Actually, said, do you mind jumping into ours? Because I don't know if we're doing what you're asking.
Cool. Yeah, no worries.
Ed. Yeah. Yep. Petra, do you want to share your screen so you can show what we're doing? So I don't know if this is actually.
Okie doke. Let's have a look at that part or that stage of trying to decouple the tests together, and then we'll jump onto the mirror board and share thoughts about what we've learned this morning, what we've uncovered. There's lots of things that are going into this, so we're going to come back to this a few times next week and the week after. So hopefully this is the beginning of the journey of thinking about how to get better at decoupling parts of your program from each other. So let me share my screen. Okay. So the task at hand was to try and find a way to decouple this move spec from the classes at the top here. So I know I've done this appropriately once my tests pass without using those classes. And so the thing to think about before starting was two things. One is, let's have a look at the function as well, so we can see it by side, is what is this function even testing? Or what is it even doing anymore? It no longer has the logic of the strings or returning strings. Those have now been moved to each of the individual car vehicle specs. So for example, the car has a move method that returns a string. So we've neatly encapsulated, let's say, put that down there. We've neatly encapsulated the car logic of returning whatever behavior it needs to from the move method and its corresponding test. So we don't need to worry about that anymore. What we need to think about is what is the purpose of this move function. And at the moment, it's just returning whatever the vehicle returns. So in the spec, we don't need to worry about specific classes anymore. So we can collapse all of this to one test and rely not on a specific class, but like a general class, like a replacement for vehicles. And this, the idea here is using what we call test doubles, something that can represent another dependency, another kind of thing. And so we can create our own. In this case, the important thing is every our test double that represents any of the vehicles has to implement a move function. So a simple way to go about this is to write, let's say, for example, a vehicle that has a move function. And at the moment, we can just say, I don't know, move to some distance. Let's give it a nice name and a test. I expect it to be called like test vehicle maybe, as an object that has a move method. If you wanted to be sort of more verbose about it, you could write a class for it. That's also fine. And then we'd have to create a new test vehicle and do it like this. So in this way, we've created I guess we don't need to call it skateboard anyway, test it moves a vehicle, for example. Vehicle. So in this way, we've created a general class, what we call a test double, in order to decouple our move function from any of the dependent classes. And we're using this idea of a test double, a generic class or object that we can use to stand in, to substitute for the classes needed.
Can I ask a question?
Yep.
So the purpose of this with the decoupling is it just to have less tests? What's like in this case where you've created a new spec file where you're just creating where you're just testing a dummy instead of the other ones? Is it purely just because there's less to do? Like what's I'm trying to understand what the...
So the purpose of, it's gone on a high level, the purpose of trying to decouple our programs is to make them easier to extend and easier to change, right? When systems are very tightly coupled, you change one thing, you have to change everything. And we saw at the beginning, if you need to change the move function, if you wanted to add more vehicles, you have to change the move function as well as adding in more classes. And so we went one step and said, okay, let's make the move function not care about any of the vehicles, just so long as they implement the move, vehicle.move like this. And so this now is we can use this wherever we want to. It's not directly coupled to any of those class definitions. Right, that was the first step.
I understand that bit. It's the testing bit that is.
Therefore, in order to test it, we need to rely not on specific classes, but just on a generic general class, what we call a test double. Right, because this no longer has any logic. It's just asking a vehicle to do some work. It just says vehicle.move. Right, there's no actual logic here apart from it forwards the method move to the vehicle. It just says, now you do your thing.
Yeah. Yeah, I understand. I suppose when you do your other tests, you kind of test it already, don't you? So I'm just sort of like...
Yeah, but it's important that this function is tested because it has to ask the vehicle to move. Right? So we need to cover this code path that says my move function has to ask the vehicle to move. And so we need a test for it. This test says we're going to call our move, and it has to make sure that we get the return value of that calling.move. Okay. Without this test, we could make this function return anything, and we wouldn't have a test case for this. So at the moment, the only thing that happens here in line in the const move is that it takes the argument and calls the move function on that vehicle. So we need some kind of test to cover that. At the moment, we're using a general class with a move function that says, if we do it properly, the move function will return move some distance because it's called that move. Yeah. When we get further into different test frameworks, we can actually catch like specific messages and make sure those methods are called. We can spy on method calls and whatnot. But the simplest way at the moment to do it is make sure that we have a test vehicle or a test double to represent that class. So when we do call it, it gets executed. So we're covering the behavior with the test. And so we've gone from the move function having all of the logic, and we've split out the vehicle logic. They all have their own tests, and now the move function at the top just needs to make sure we call that move method. Good question. Other thoughts and questions?
So the test vehicle would always, like the function would always do the same thing as the original function. You're just using it as a test.
Exactly. Yeah. It only exists for the purpose of the test. It's a test double. And usually
I guess I'm a bit confused.
Yeah, go ahead.
Why you would move all the car tests to like its separate thing? Because wouldn't it make sense to have all the tests in one spec, so it all does the tests together instead of having them separate?
So each individual class is responsible for its own behavior. So we've separated out the behavior into classes. The car and the plane and skateboard, they all have their own functions. They all have their own specs. And that's just the general pattern that we follow. Each class has its own spec. And as a result, in this example here, we have to make sure that we're still testing what the high level function move does, which is called the move function on each vehicle.
So for example, in the airport challenge, we'd have a different spec for the airport and a different spec for the plane if we were testing things on the plane.
Exactly, yep. Every class has its own spec. Every unit test has its own, yeah. More questions and thoughts?
Have you got the same class in every spec folder?
Paraphrase that for me.
So you, sorry, where did your other 4 tests go? They're in their own individual spec folders, right?
They belong where the logic is, right? So we move the logic from that move function into each individual class: the car, the plane, and the skateboard, and the spaceship. As a result, each of these classes need their own spec. So the car has its own spec, the plane has its own spec, the skateboard has its own spec, plus the spaceship, which I haven't written. So they all have their own spec. Yeah, we move the logic from one place into where it should be, thinking about encapsulation, into the individual classes responsible for them. As a result, we can now test or change any of the vehicles. And we'll only need to go to the car spec or whichever spec that we need to make sure that still passes. And we don't need to worry. The move function shouldn't care. As long as the vehicle has a move function, it shouldn't care about it. Yeah. We're trying to decouple these things, making sure each object is responsible for itself, has its own set of tests. And as a result, anything that needs them, we just double those dependencies at that level when we test it. Because it doesn't care. We shouldn't care. We should make sure these things are decoupled.
Surely there's only. Sorry, I coughed. So you
go ahead, Zach, or whoever it was.
I was just going to say. So is this to like make your code more and more modular so you can like use it, reuse it should you want to in a different project or something like that?
Yep, and in different parts of your program, you want to be able to keep things super modular and in small parts. And we're always thinking about how to break up big programs into smaller bits. All right, and there are some other benefits that we'll have a look at, or they'll emerge over the next couple of weeks.
Cool. Go ahead, Jamie.
Yeah, surely this is only useful when you have like numerous complex classes that are big, rather than this example where they're all kind of small. Like if I was making this, if I was making this, you gave me a brief, you wanted me to make this, I probably wouldn't separate them. I'd just stick them all in one class for now because they're not really doing anything complex and they're not going to be that big.
So yeah, it's a great question, Jimmy. And remember that every time we workshop something, focus less on the domain and focus more on the skills that we're trying to improve, right? And then the second part of this is you always write code for other people, and in the understanding that it will last a while, and so people will need to come back to it and understand it and extend it. And so I'd always expect you, where possible, to apply good design always. Even if it's a small project. Now, if it's entirely for yourself and you're the only other user of it, feel free to write as much as you want in the way that you want it. But as soon as you start writing code for other people that they have to then take it and extend it, always think about good design. Now, there's going to be a trade-off as well. So the more you think about design, the less time you have to write code. So sometimes there are competing priorities. If in the business, like you're on a really tight deadlines, you'll sometimes have to compromise on something. Sometimes you'll compromise on the number of tests that you have to write, the speed at which you do things, and some other things. But you still build up technical debt, which at some point has to be resolved. Technical debt is the idea that bad design or essentially bad design or bad ways of working will lead up to costs later, and sometimes it becomes a prohibitive cost. So we should always be trying to find ways to reduce technical debt. That's why sometimes you'll hear of massive rewrites of entire systems, because technical debt got such to a point that the cost to keep moving forward and adding additional features was incredible. So it would be much easier to just rewrite everything from scratch. And it's not a good outcome, but it happens. Yeah, cool. Any other thoughts or questions?
Yeah, I just wanted to clarify. When you say you're writing it for users, I presume you mean other people you're coding with rather than the people who are eventually receiving it.
Primarily, yes. Because other people won't read your code, right, if they're users. But your teammates and your future teammates who don't exist yet will read your code. Cool. Okay, so let's wrap up there in a second. So what I want to do is let's go back to the objectives. Zoom windows go away. So the two specific objectives we had this morning was to explain what coupling is. So give me a quick thumbs, like, yep, I can explain what coupling is, as at least in regards with classes. This is like not really, kind of. This is like coupling. Is that English? Cool. When you think about it, think about if you're not quite certain, what do you need to do? What information do you need to figure out how to explain it better? It's good because when you demonstrate these things in interview, coming out with things like cohesion and coupling comes across really well when thinking about how people program and your understanding of them and examples that you've had. These are things that some people don't have words or the terminology to describe, and so you'll be spending lots of time thinking about these things over the course. Okay, the second objective was to refactor code to go from tight coupling to loose coupling, and we've done a couple examples. And how do you feel? This is like, yeah, pretty good. This is like, I need more work. This is like lost. give yourself a rating. Cool. So we're going to continue with this exercise next week, thinking more about the test doubles and how can we test drive this, and thinking about couplings. So we'll come back to it. From next week onwards, I want to sort of expect that we'll be using test doubles primarily when trying to test drive our code. So I'll introduce that again on Tuesday morning. But for this weekend, don't worry about it too much. If you want to play around with trying to use test doubles in your code, absolutely have a go. But that's not expected until next week. Always be thinking about coupling and modularity and how to break up your program into smaller pieces. Cool. All right, that's it for this morning. I hope that's enjoyable. There's still more work on the balance and wallet example if you want to have a go at that, making sure it's decoupled and the tests are also isolated. Otherwise, the rest of this morning is individual time, and then we'll get back together after lunch. Sound good? Cool. Good stuff this morning, and see you later.